Today's lesson's on family of functions. We're going to look at a bunch of graphs and match them up with the name of their functions. So the first function we're going to do is the absolute value function. And we know that the absolute value function, the graph looks like a V. So if we see a V, we know we have an absolute value function. What does that equation look like? F of x equals the absolute value of x. So if we see the absolute value bars, then that means we have an absolute value function. Linear function. Exactly what it means. We have a line. So if we see a line, we have a linear function. And that's just f of x equals x. We could have some things added or subtracted on or multiplied or divided to these functions, but in the last one, the absolute value, if we see the bars, it doesn't matter what else is there. We know we have an absolute value function. How do we know we have a linear function here? The highest exponent is 1. Quadratic. What's the quadratic graph look like? We have a U. So it looks like a U. So if we see a U, we know we have a quadratic function. And what does the equation look like? F of x equals x squared. Highest exponent is 2. We could have some other things added or subtracted on or multiplied, but the highest exponent is 2. If I see a u, we have a quadratic. If I see highest exponent is 2, we have a quadratic function. Cubic function. Let's look at the equation first. F of x equals x cubed. Highest exponent is 3. Again, I could have things added or subtracted on. Cubic. I have my arrows pointing up and down. I have another cubic. This cubic looks a little different than the other cubic. Still has the same equation, highest exponent of 3, but notice here I have 2 vertexes or 2 turning points. Therefore, I add 1 to make 3, and I have highest exponent of 3, which is a cubic. Square root. Look at the graph of a square root. Looks like half of a quadratic or half of a u turned on its side. And my equation is f of x equals the square root of x. I have that square root. So if I see a square root in my equation, I know I have a square root function. I know that if I have half of a u turned on its side, now that side could be turned that way. I could have it that way, or I could have it this way. So notice, all these are the square root function. Cube root. Very similar to the square root, but I'm going right and left. Notice, cube root looks similar to cubic. Cubic, my arrows are going up and down, where my cube root, they're going left and right. And the function f of x equals cube root of x. I'm going to have that cube root symbol. Fourth degree polynomial. How many vertexes do I have? 3. Add 1 to make 4. Equation, f of x equals x to the 4th. Highest exponent of 4. Fourth degree polynomial. Again, I could have some things added or subtracted or multiplied or divided by that x to the 4th. exponential. Okay. Here's one of my graphs. I could have it looking the other way too. Here. I could have it going down. Either one of these four graphs, they're all exponential. They look similar, but just a little bit different. And let's look at our equation. F of x equals, notice where my variable is. The variable is in the exponent, therefore that's why we call it exponential. Logarithmic. Looks very similar to exponential. Exponential, my dotted line is a horizontal line. In logarithmic, my dotted line is vertical. Yes, I could have that on the other side. This is a very easy one again to notice in our equation. F of x equals log x. It has the word log in it every time. So if we see that word log, we know we have a logarithmic function.